Okay, so this is another great example for finding inverse functions. It has a restriction placed on x, a strict inequality that you see here. And it's just a technicality, and I'll get to that in a moment. So yeah, it's a really specific case of a problem. It's a little technical, but it's worth doing, especially if your pre-calculus teacher covered it. So to find the inverse function, we need to do some algebra. So instead of using function notation, it's convenient to represent f of x as y. And to find the inverse, we want to swap our x and our y's. So that's the first step. Again, I replace my x with a y. Good. And the next step is multiply both sides by the denominator. This equals y squared minus 16. Notice that it's very tempting to identify this as the difference of two squares. Since it takes that form, you could factor it as y plus 4, y minus 4. But it wouldn't make our algebra easier. So that's why we leave it alone, because we don't want more y's floating around. Subtract y squared to both sides. And I'll just continue in the upper right corner now. Again, we want to reduce the number of y's floating around. We want one y floating around. So factor out y squared. This allows us to isolate it. Divide both sides. So we get negative 16 divided by 5x minus 1. Now, I square root both sides. Normally, when you square root both sides of an equation, you tack on a plus or minus to indicate that you have two solutions. But in this case, we just want one solution. So this becomes y. And of course, we want one solution because we want one inverse function that corresponds to our original function. Next, yeah, I see this number here is a perfect square. I want to take the square root of it, but it's a negative. So I'm going to factor -1 out of the denominator. So negative, and then change the signs. Negative 5x plus 1. This allows the negatives to cancel, leaving us with y, which is the inverse function, is 4, the square root of 16, all divided by radical 1 minus 5x. It got a little messy at the bottom. So that's the method in finding the inverse. Next, you could find the domain and the range of each. So I just want to briefly show that. So how would you find the domain of the original? Well, to do so, the denominator cannot be 0. However, since they gave us an inequality symbol, we use the symbol they provided for us. So we're going to use this for the domain. So format it as follows: the set of all x such that x is greater than 0. Next, finds the range of the original. Now, to do so, take the opposite of each thing provided. So the opposite of range is domain. The opposite of f is f inverse. So the range of f would be the domain of its inverse. Okay, so the domain of the inverse would be the expression under the radical must be greater than or equal to 0. Now here's where the technicalities come into play. We want to use the inequality symbol that they provided for us. Theirs did not include an equal sign. Another way to interpret this is that notice how our radical is actually in the denominator. So yeah, this expression cannot be equal to 0 since it's in the denominator. So anyways, enough of that. Subtract 1 to both sides. Another technicality, divide both sides by -5, which flips the inequality symbol. So that's the domain of the inverse. So the range of the original function is all y such that y is less than 1/5. Let me create some space. Next question, almost done. Part 3. What is the domain of the inverse? Okay, find the opposite. This is the range of the original. Okay, but the range of the original is part 2. So this is all x such that x must be less than 1/5. Again, it's the same as part 2, but it's formatted with x because ultimately we're interested in domain. And the last question would be, what is the range of the inverse? This would be the domain of the original. I format this with y for range. Y must be greater than 0. So notice that part 4 should be the same as part 1. And part 2 should be the same as part 3. Let's look back at that one last time. Part 2 is the same as part 3. So that's how you find the range and domain of each equation, both the original and the inverse.